doing? Good day, geometry. We are on the home stretch of our unit on radicals. And actually, the good news is you've already done CO63 kind of sporadically throughout. You have multiplied fractions before involving roots, or multiplied expressions involving roots. You've divided them when you rationalize. Now it's kind of putting it all together. And like we saw in CO62, where the rules you've used to add fractions and add variable expressions also apply to roots, and that you have to have the same root, and only the coefficients get added or subtraction, the root stays the same, kind of those things. Similar with multiplying and dividing, okay? With fractions, 3/7 times 9/10. What gets multiplied here? How would you multiply 3/7 times 9/10? I'm not facing you right now, but when I turn around, I hope there are 26 hands up in the air, otherwise I'm gonna feel very sad. Peter, how do you multiply fractions?
You multiply the numerator and the denominator.
What do you mean?
You multiply the 3 and the 9 and the 7.
Okay, thank you, Peter. Yes, you multiply going straight across. Do the denominators need to be the same? No. 3 times 9 is 27, remains in the numerator. 7 times 10 is 70, remains in the denominator. How about 3n times 4y? If you're multiplying, do those variables need to be the same? In other words, do like terms exist when you're multiplying? No, they do not. How would you multiply 3n times 4y? What would your expression be? Right, so what would our new coefficient be? 12, right? The coefficients get multiplied. 3 times 4 is 12. And our variables aren't the same, and that's okay, because we can just write it as ny. The rules are different for multiplication and division than they are for addition and subtraction. So when we get to roots, it's the same idea in that we're multiplying the coefficient by the coefficients. So 5 times 2 would be 10. And we're multiplying the root by the root. And here's the best part, folks. Those roots don't have to be the same as when you're adding or subtracting. Just like our denominators and fractions don't have to be the same, our variables don't have to be the same. We simply multiply 3 and 7, and that product goes under the root. So 10 root 21. Right?
Cool.
Isn't that great?
That's so awesome.
Yeah, thanks. Thanks for sharing that thought. Yeah. What's that? Well, it's already started, so you're in it right now, Maggie.
So he doesn't have to wait. That's great.
So the only thing you have to watch out for is whether or not you can simplify when you're all finished. So if we go down to the practice work here, 2 root 10 times 8 root 2, I'm multiplying my coefficients. 2 times 8 is 16. I'm multiplying my radicals. 10 times 2 is 20. This would not be a final answer. Okay? Just like if we could simplify the fraction 27/70ths, you would have to. If you can simplify that radical, then you have to. Okay, so it again goes back to PO61 in that simplifying piece, which is why it was a PO in the first place, right? Yeah.
So would you then just switch it to 4/5?
So you would rewrite this to be 16 times root 4 times root 5, right? You want to pull out that perfect square factor from 20. That root 20 is a 4, or sorry, that root 4 is a 2. So you get 16 times 2 times root 5. And so our final answer would be 32 root 5. Okay? That's about it. That's about it. Okay? Questions so far? Okay. Oh, you know I'm going to have some fun with this objective. You just know it's going to get good.
Oh no. Oh no. Wait,
You're so nice.
9 root 8 times 3 root 5. See, the beauty of this is that so much you can do with radicals that once you learn how to multiply them, we can go back to, I mean, what do we got going on here? Middle one, second page. What is that?
Disgusting. That's what it is.
Who recognizes the process that we'll need to use for
Crab
You know,
claw.
it's not the last
Crab
lesson.
claw.
It was the last
old man
No,
foil
crab
crab claw?
claw.
It's all coming back, folks. It's going to be a great day.
So why didn't we just learn this last year?
We were going to. We ran out of time. Yeah. Hashtag your teacher got COVID, so it was out for 16 days. How about that next one there? 9 root 8 times 3 root 5. 9 root 8 times 3 root 5. What's that going to give us? Before simplifying. Just do the basic stuff first. Gino. 27 root 40, right? Coefficient times coefficient. Root times root. 27 root 40. Okay? Those roots don't have to be the same. We can just multiply them. Now to simplify that root 40, what factor pair are we working with? Drake? 4 and 10. So we have 27 times root 4 times root 10. That root 4, that perfect square, becomes a 2. And our final answer, close, 54 root 10. Okay. Any others? Let's do the third one in that second row there. That looks fun. 6 root 10 over 4 root 4 times 2 root 2 or 5 root 5. Okay. Now we're multiplying roots in fractions. And we got really annoyed with Mr. Schultz in the last subjective when we added roots within fractions because getting that common denominator was kind of a beast. And I said, don't worry about it till algebra 2. This will be on the test because the rules are different. Do we care that 4 root 4 and 5 root 5 are different? No. How do we multiply fractions? We go straight across, right? So we're going to start with 6 root 10 times 2 root 2. And the numerator of our answer is going to be 12 root 20. 6 times 2 is 12. Root 10 times root 2 is root 20. Then our denominator, again, multiply straight across. 4 root 4 times 5 root 5. We're going to get 20 root 20. And now we realize that Mr. Schultz is a pretty nice guy after all, because what do you see? Caleb?
It's easy to simplify because it's the same.
Same root? What is root 20 over root 20 simplified to be? What can we do with those? Cancel them out, right? Anything divided by itself equals 1. So our roots can be eliminated because they're the same. And that leaves us with 12 20ths, which would simplify to be 3/5. And that would be our final answer.
Wow.
See? Not so bad.
Pretty bad.
Take back all those things you just muttered about me under your breath when you were... let's do one of the ones with variables. Which one of the variable ones do you want to go over here? Peter? The last one? Okay. I don't know. It's a thing students have. Yeah, I suppose. A tradition unlike any other. The last one. 5x squared root 5x times root 5x. Our second radical expression here doesn't have a coefficient, so that 5x squared, nothing to multiply with, is going to remain 5x squared. And then root 5x times root 5x, what does that give us? Joey?
5x.
Ultimately, yes. After we realize that I'm not such a monster after all, right? Because under the root, what do we get? 25x squared. And we look at that root 25x squared and we realize what? Yes, we have simplified it, but what do we see? What? Mackie?
5 can go into 25.
25 is a perfect square. And Zinni? the x squared is a perfect square also, right? So our 5x squared out in front, we haven't really done anything with that yet, but then this root of 25x squared simplifies to be 5x. And so what's our final answer? Blake? 25x cubed would be our final answer. Okay? Who's in the mood to crab claw?
Old man crab. It's old man crab.
All right. Let's go back to basics here a little bit. What does FOIL stand for? No. Adam, do you remember? First, outside, inside, last. And what those four words refer to are the position of the terms within their parentheses, right? So for the F, the first, we are multiplying those first terms together. And what does 2 root 2 times 2 root 3 equal? Joey? 4 root 6. Okay? The O, or outside, we're multiplying those outside terms. Oh, this is going to be a good one right here. Multiplying those outside terms together. 2 root 2. Don't forget it's a negative 6 root 2. Sometimes that sign gets forgotten. What do we have? What do we have? Well, negative 12 root 4. We'll deal with the simplifying in a little bit. Okay? The inside terms, root 15 times 2 root 3. What do we get? 2 root 45. And the last terms, hey, old man, root 15 times negative 6 root 2. What do we get? Negative 6 root 30. Okay? Any questions on this much? The multiplication isn't, I mean, if you understand, if you've got that connection down between coefficient times coefficient, root times root, the numbers here aren't challenging. You've got a negative sign to deal with. You can't forget about that. You've got, how you multiply first, outside, inside, last. So you have to remember that. But the math isn't challenging here as far as what you're actually multiplying. Now let's simplify. Can we simplify 4 root 6? No. So that one is done. What about negative 12 root 4? What does that become? Negative 24. That one's done. 2 root 45. What does that become? Think of that 45. What's that per square factor? 18 root 5, not 18 root 5, because it's root 9 times root 5, but that root 9 becomes a 3, right? So it'd be 2 times 3 for 6, and then root 5. And that one's done. How about 6 root 30? Can we do anything with that? 3 and 10? No. 5 and 6? No. 2 and 15? No. So that one's done. Okay? Can we combine any of those four terms with addition or subtraction? Because remember, once we do this multiplying, now we've got these four terms that we're looking to combine if we can. Can we, Mackie?
Should we just add them all up into one big one?
That sounds like a horrible idea. But thanks for bringing it up, because why can't we combine these terms here, Caleb?
Because when you're adding and subtracting, they have to be the
Right,
same.
because when you're adding and subtracting radical expressions, the radicals have to be the same. Okay, so our final answer is just going to be 4 root 6. Let's see. We'll put our constant last. The order here doesn't really matter that much, but typically, if you have a constant, it would come last. But there you go. That's yeah. Should we do the next one together too?
Yeah, that's a good idea.
Yeah.
Great idea.
That'd be
Okay.
awesome.
Yeah. I'll do this one. I'm really only doing this one because I really want to draw the crab claw, to be honest with you. Okay. Does everybody have the notes here? I'm gonna have to erase some of this stuff. Anyone still need the notes? I'm glad you think so. I came into school with a pep in my step because I knew I'd be teaching this one today. I was really pumped.
I came to school with a rock in my shoe. For offense.
Okay, done? Okay. So looking at this next one here and using crab claw. Remember, crab claw is just a different order of multiplying things. We're still going to take our 6 root 3 and we're going to multiply it by 3 root 2. Okay? And I'm actually going to let you do the math from here on out. I'll just get you started. Like I said, all I want to do is draw the crab claw. So I'm going to draw the crab claw, and then you can do the rest of it. All right? Then we take that 6 root 3 and multiply by negative. That's not going to be a very good one. 6 root 3 times negative 5 root 18. Then we go underneath, and we've got a negative 7 root 2 times 3 root 2. And then, again, that negative 7 root 2 times negative 5 root 18. Crab claw! And there we have it. Okay, so just like in the previous one, once you multiply these, simplify them, and then look for anything that you can combine with addition or subtraction. Ooh, I think there is one that you can do. 2 of them actually. Yeah, this is a good one. Okay. What would you do for the first one here? 3 root 3 times 2 root 2 plus 4 root 4. What would your method be here? Just distribute. Yep. 3 root 3 multiplied by 2 root 2 multiplied by 4 root 4. Okay. Questions on multiplying roots? Okay. Dividing roots. Yeah. We only got 2 more pages to go. No. I'll keep you in suspense. Where you've divided roots previously is in rationalizing the denominator. Okay. When you've got 5 divided by root 3, since the 5 and the root 3, one's in a root, one isn't in a root, we can't actually divide them. So we would rationalize. And who could remind us what that process is to rationalize this fraction here? Yeah. Yes, we multiply by the root on the bottom over itself, right? So root 3 over root 3, which really is just a really funky way to write what value? Anyone know? Yeah, 1, right? Which is why we're able to do this, because it doesn't change the value of the fraction. We're just multiplying by 1. But what it does is our numerator becomes a 5 root 3. Now you know why we had to leave it as 5 root 3, because 1's a coefficient, 1's under a root. You can't actually combine them together, but you can still multiply them in this form. And then 3 root 3, or root 3 times root 3, we know that those roots cancel out. What's really happening is you get a root 9, and now you know why, because you can multiply the roots together, and that gives us a 3, and that would be your final answer. Okay? So you've kind of done this before in the rationalizing piece. So there's a bit of review for that. But let's get down to the fun stuff here. Any of these four you want to see done? Drew, the last one. Okay? You can treat these, no smacking, please. You can treat these kind of like you can treat exponent expressions when we divide it by the same base, in the sense that you kind of look at your coefficients and your roots separately. Can you simplify 25/7? No. Can you simplify 8/5? No. So what are we going to do here? And you've got options, but what do you want to do? No, don't do that. That's not an option. Just leave it is what was said. No. Peter,
Rationalize again.
we can rationalize. And that's going to open up some things for us to do. We can multiply by root 5 over root 5, which gives us a numerator of what? Gino, 25 root 40. And a denominator of what? Drake? Ooh, well done. Yeah. Where Drake got that from is because 7 root 5 times root 5 becomes 7 root 25. That root 25 being a perfect square, we can get 25 root 40 over 7 times 5, right? That root 25 becomes a 5, or 25 root 40 over 35. And we're done? No. What can we simplify? We're never done in this class. You said that. There's always something more. What can we simplify, Peter?
25 over 30.
We can simplify 25 35ths if we want. Since they're both outside of the root, it's legal to do that. What does that give us? 5/7? Are we done? No. What can we do now? How do you, well, we already did. We don't have a root in the denominator to rationalize with. But it's not a bad guess, right? I mean, it's one of the things we could do. Caleb?
You take the square or the root of 40 and you can do change it into 10 root 10.
Yep. So this root 40, we can break that apart into 4 and 10. Root 4 times root 10. That root 4 is important because that becomes our 2. The root 10 we can't do anything with. That doesn't really make a difference. So our final numerator, I hope you left more room on your page than I did here, is 10 root 10 over 7. Now are we done? We are. That's it. 10/7 can't be simplified any further. Root 10 can't be broken down. There's no root in the denominator. Okay. Basically, your checklist for whether or not you can simplify is root in the denominator. Check that. Check your coefficients vertically. Check your root in the numerator. Can it be simplified? So if you go through rationalizing, coefficients, roots, those are the 3 things that you could potentially simplify when you've got these fractions here. Okay? It's ridiculous. Any others that you can see on the page that you want to go over, including the ones on the second page there that are visible? Third page. Caleb,
Can we do the last one?
is it visible? No.
Oh wait, can we do the last one?
What's visible? Sure, 6 root x over root 3x. Okay. Sometimes it can be helpful to run through your checklist at the start. Do I have a root in the denominator? Yes, so I'm going to have to take care of that. Can I simplify my coefficients vertically? No, because I only have one coefficient there. Can I simplify my roots vertically? Yes. And that might actually be helpful. Why? To start with that instead of start with the rationalizing here, why might it be helpful to start with simplifying those roots vertically?
Because after you simplify the 3x, you still have to simplify, rationalize it again, and simplify.
Either way, we'll have to do both of them at some point. But why might it be better to start with that vertical simplification first? Caleb?
Because if both of those x's can cancel out.
Right. We have a root x, because remember here, that denominator can be rewritten to be root 3 times root of x. We can break that root apart into things that multiply it. So now, since we've got a root x in both parts of the fraction, they can cancel out. We do still have a root in the denominator that we have to deal with, but at least we've gotten completely rid of the variables. And so now it just becomes 6 over root 3. You rationalize, you simplify again, and then you're done. Yeah, you can simplify again. Yeah. Okay. Another one that's visible. We're slowly working our way down. That you want to go over? Blake?
The last one.
The 14 over 56 root 3? Yeah? I said that is visible. Yeah, so that's what you want to do? Okay. So 14 over 56 root 3. Do we have a root in the denominator? Yes, we do. Can we simplify our coefficients? Yes, we can. Let's start there. How can we simplify these coefficients? Sydney. 1456, we can divide both by 7, and that gives us 3/8. 2/8, sorry, which we can simplify further to be 1/4. Okay? So 1 over 4 root 3. 1456 can be simplified to be 1/4. What? And then, yeah, sorry. 1456 ultimately simplifies to be 1/4. And then we have our root 3 there that we can rationalize from there. Okay? Any others that are visible? This one's not finished yet. You can take it home, hear it from here. But any others that are visible that you want to go over? Maybe someone we haven't heard from yet that wants their opinion heard. You want to voice your positive energy. Drew?
The middle one on the bottom.
24 root xy?
Good choice.
Yeah.
Good choice.
All right.
Hey, we know that was
Okay. Tell me look at this. Run through your checklist. Rationalize coefficients, roots. Tell me where it's going to be most efficient to start this. Say that again, Drew.
We get the x out of the top
How?
by putting x to the fifth in expanded form.
Okay. So notice that we've got an x term under the root in both the numerator and the denominator. We can get rid of that x in the numerator by canceling it out with one of the x's in the denominator. In our numerator, that leaves us with 24 root y. In our denominator, it leaves us with 2 root what? X to the 4th. Why does that make us happy inside? It should. Joey? It's a perfect square. Right? It's a perfect square. So now we can rewrite this expression. We're not going to touch the numerator yet. That's still going to be 24 root y. But in the denominator now, take the root of that x to the fourth. And what's the root of x to the fourth? You have a chart that might be good to put on a help sheet. The root of 24x to the fourth, remember the rule?
X squared.
X squared, just cut that power in half. Okay, so to recap what we've done here, we canceled out our root x in the numerator with one of the x's in the denominator, leaving us with x to the fourth. We then simplified root of x to the fourth to be x squared. And that's where we are now. What comes next? Mackie?
We're done.
No, Mackie. We're not done. There's more to do. Joe?
Oh, you can simplify 24.
We can simplify our 24 halves, or 24 divided by 2, which equals 12. Now, surely we must be finished.
Yes,
And we are. Okay? Let's go indeed.
Let's go, Caleb.
Okay, let's go indeed. Your homework for tomorrow.
See, it doesn't want you to scroll down. It doesn't want you to. Don't scroll up.
Really ruin the moment. Okay, I would like you to do everything up until.
Stop. We can do the whole assignment. No.
There.
Just go through.
No, everything up until the green line. Everything up until the green line. What do you say? I didn't even hear what you said. Probably better. I'll just go back to the recording and listen for it.
You're so redundant.
Okay. So homework for tomorrow up until the green line. We'll wrap this up tomorrow. Dabble with CO64 tomorrow. Well, we did like 10 of them. I mean, we did both the foil crab claw ones. I mean,
Yeah, we got old man crab claw.
yeah, you get to crab claw. What could be better? Thanks for saying. All right, folks, that's how you math.